Hello, and welcome to the first video in our fifth class time series of lecture videos for second semester organic chemistry. Today, we're going to embark upon discussing benzene and benzene derivatives. We may even get to a crude molecular orbital diagram description by the latter videos for this class time. In this first video, we're just going to look at benzene and some benzene derivatives. So in 1825, Michael Faraday isolated a colorless liquid, boiling point 80.1 degrees Celsius, melting point 5.5 degrees Celsius, by the pyrolysis of whale oil. It had an empirical formula of CH. It was an unusually stable and inert liquid, and a molecular formula was determined for it of C6H6, and it was named benzene. Various chemists proposed various structures. This was the time before NMR. We have duobenzene, which is kind of interesting. Claus benzene, which is a little crazy in terms of bonding. And then, of course, Ladenburg prismane. In 1865, about the time America had resolved what kind of country it was going to be, Professor August Kekulé at the University of Bonn, Germany, proposed that benzene can be viewed as both resonance forms of cyclohexatriene. And here we have a six-membered ring with three double bonds, and of course, because it's a conjugated pi system, one could easily think of this molecule as two different resonance forms. I know I've told you guys that resonance is a lie, and yeah, we'll be looking at a molecular orbital description of benzene soon enough. Another way you might see these benzene rings drawn is a six-membered ring with a circle inside of it to sort of symbolize that we have a conjugated pi system with 6 electrons. So, continuing forward, let's look at nomenclature for benzene derivatives. For monosubstituted benzene, we add the substituent as a prefix to benzene. So, for example, here we have chlorobenzene. So we've substituted one of the 6 hydrogens for a chlorine atom. Here we have ethylbenzene. This is a great standard that's used in the calibration of NMR instruments. Common names of important monosubstituted benzenes, please memorize them. You come across these things in life, and it's nice to know what they are. Toluene is methylbenzene, and it's used as a solvent, can frequently be found in paints. Phenol is an antiseptic. It's also a bit of an anesthetic, topical. Aniline, this is a dye precursor. So we've got an NH2 attached to our benzene ring, whereas in phenol we had an OH. Here's benzaldehyde, which is a very potent flavoring agent. So we've got an aldehyde group attached directly to our benzene ring. Here's acetophenone, which is a hypnotic drug. There's benzoic acid, which is used as a food preservative. Sometimes you look at your processed foods and you see a lot of the sodium salt of benzoic acid, so sodium benzoate. Here's styrene, which of course is a monomer for polystyrene. Those interesting insulating polymers that dissolve easily in acetone. We can also think of benzene as a substituent or a group. And so when we are thinking of benzene as a substituent, here we have our aromatic ring, our benzene ring, attached to some R group. We could call that whole aromatic ring a phenyl group, and we abbreviate that as pH. So, for example, this might be called 2-phenylethanol because we've got this phenyl ring at the 2 position of ethyl alcohol. You could also symbolize it as a benzyl group. And so what is a benzyl group? It's basically a phenyl ring attached to a CH2 that's bonded to some R group. And sometimes we abbreviate that as BN. So this would be called benzyl bromide. How about disubstituted benzenes? Now we're adding a couple of groups. In this specific example, we have two bromine groups, and they're attached at relative positions of 1 and 2. So you could name it 1,2-dibromobenzene, but we have another name for this kind of substitution pattern on a benzene ring. We would call this ortho-dibromobenzene, or O-dibromobenzene. So the ortho denotes a 1,2 relative substitution pattern on an aromatic ring. How about this guy? This guy would be called 3-chlorotoluene if we use the common name for methylbenzene. Otherwise, if you were to use an IUPAC, you might call it 1-chloro-3-methylbenzene. Another way we describe a 1,3 relative substitution pattern on aromatic rings is the use of the prefix meta. So we could call this meta-chlorotoluene, and we would all know what we were referring to in terms of structure, or M-chlorotoluene. So ortho means adjacent, substitution, a 1-2 pattern. Meta means a 1-3 relationship. We've got one other relationship that we want to discuss. Here we've got a couple of examples. Here we've got 4-nitrobenzaldehyde or para-nitrobenzaldehyde. So this is a relative 1,4 substitution pattern. And sometimes we symbolize that as just p-nitrobenzaldehyde. So para is a 1,4 relationship. Here's another example, para-methoxy benzyl alcohol. There we go. How about tri-substituted benzenes? To name tri and more highly substituted benzenes, we number the 6 carbons of the benzene ring with the lowest set of locants. That means the lowest set of numbers that we can generate. And then we label the substituents as in cyclohexane nomenclature. So here we've got 1-bromo-2,3-dimethylbenzene. Here we've got 1,2,4-trinitrobenzene, probably explosive. We wouldn't want to say that it's 1,3,4-trinitrobenzene. We'd want to use 1,2,4 to generate the lowest set of locant numbers. And then, of course, this is a fun one, right? 1-ethynyl 3-ethyl 5-ethynyl benzene, because we use, alphabetical order in our naming scheme. How about some aromatic flavoring agents? I love flavoring agents. This guy is 4-hydroxy-3-methoxy-benzaldehyde, otherwise known as vanillin. And it's something plants generate and incorporate into other interesting natural products that you might see later on. Here's 5-methyl-2,1-methyl-ethyl phenol, or thymol. So nature makes use of aromatic rings and creates some interesting molecules that plants produce and we can appreciate through a deeper understanding of our organic chemistry. And with that, I think I'll end this video and I'll see you in the next one.